Hello, I hope you all are doing great. Today we are going to discuss about motion sensors. How many types of motion sensor we are having and uh, why we are going to use that motion sensor, and we are going to go deep dive into one of the motion sensor, that is the PIR, passive infrared sensor. Yeah. So I'm going to share the screen and we are going to discuss about motion sensors and about the PIR sensors. So what is the motion sensor? Motion sensors are the sensor which is going to detect the motion of any object. Yeah. So motion sensors is going to detect the motion. By its name we can say, yeah. So how many types of motion sensor we are having? We having PIR, passive infrared motion sensor. We have the ultrasonic sensor as well. We can detect the motion using the ultrasonic as well. Ultrasonic sensor. Ultrasonic we have discussed earlier, isn't it? Yeah, and we can use some microwave sensor as well. Microwave sensor. And what we can do, we can use tomographic sensor as well. So PIR sensor detects infrared radiations changes. Ultrasonic sensor emits ultrasonic waves and measure reflection and time to detect the movement. And microwave sensor emit microwave pulses and measure the reflection to detect motion. And tomographic sensor uses radio waves to detect motion within area. Yeah. So radio wave, microwave, ultrasonic, and infrared. So we can use these type of waves to detect the motion. And today we are going to discuss in detail PIR, passive infrared sensor, and how it is going to work, and how we can connect it with Arduino, how we can do that code. We are going to discuss all the things in details. Yeah. So first of all, we are going to discuss about the infrared radiation. Infrared radiation, IR radiation. So infrared radiation is a type of electromagnetic radiation. So IR radiation are the electromagnetic radiation. And IR emitted by all objects that have heat. Yeah. The most important point is heat. All the object who is having the heat, it emits infrared radiation. And the amount of infrared radiation emitted by an object increases with its temperature. The amount of infrared radiation emitted by an object increases with its temperature. Okay. And so what is the connection between the IR and human bodies? So human bodies emits infrared because they are warm. Yeah. So human bodies also radiates IR. Yeah. Human bodies emit IR. Why? Why? Because they are warm. They are hot. And This infrared radiation can be detected by the sensors, which is like like PIR, so they can respond to it. Yeah. So this is infrared radiation. So it can be emitted by any object who is having the heat, and it connect with the human body as well, because human also radiate or emit IR radiations, because human bodies and animal bodies are warm. Animals also emit uh, IR radiation because they are warm. Okay. Now we are going to learn about PIR sensor and structure and function. We have learned about IR radiation. Who emit IR? Every object that is having the heat, it can emit IR radiation. Now, PIR. PIR stand for passive infrared. Passive. P for passive, I for infra, and R for red. Passive infrared. Okay. So first of all, what is the design of this sensor? Design. So a PIR sensor consists of two slots or elements made up of special material that is sensitive to infrared radiation. This sensor is having two slots. This sensor having two slots or element, and these slots are made up of special material, and this material is sensitive to the infrared radiation. Okay, the two slots are IR sensitive. And these elements are positioned side by side within the sensor. So if one slot is there, then second slot is can be there. Okay. So this passive infrared sensor, PIR sensor, having two slots, and those slots are made up of a special material, and that material is infrared radiation sensitive. And these two slots are present side by side inside the sensor. Okay. Now how? So it is the structure of that PI sensor. Yeah. Now how it is going to work? So working related to these two slots only. Working. So when the sensor is idle or there is no motion in its field of view, both slots detect the same amount of infrared radiation from the background environment. Yeah. Let's suppose that there are two slots. If the sensor in idle condition means there is not any motion by any object, then both slots detect the same amount of infrared which is coming from the environment only. This balanced state means no signal is sent by sensor. Yeah. So that means everything is in the rest. Nothing is in movement. Now what we have differential detection. So when any warm body like human, animals, enters the sensor's field of view, maybe it is going to be enter inside that sensor area, then it disrupts the balance. Before that, sensor was in ideal condition, no movement, same IR radiation it will get from that environment. But when a human body or animal body which having the which have the warm body, which having the heat inside it, when that type of body enters the sensor's field of view, it disrupts that balance. How? The moving object causes change in the amount of infrared radiation detected by one slot relative to the other slot. For instance, as a person walks by might pass in the front of one's first slot. There. Then it increases IR radiation around this slot. Yeah. The IR radiation around this slot is going to be increased, and IR radiation around this slot is decrease. Means there is a change in infrared radiation around both of the slots. As this body is going to be cross from this point to that point, then IR radiation around the second body is going to be increased. Sorry, around the second slot is going to be increased as compared with the first slot. So again, the balance is going to be disrupted. Yeah, and radiation is going to be increase or decrease around the slots. So PIR sensor detects the change in infrared radiation as a differential signal. So what it generate? It generate differential signal around two slots when a warm body like animal and human is going to be enter inside that field of view. That means the infrared radiation is going to change, and due to this change a differential signal will generate. The sensor's internal circuitry then converts this differential signal into the digital output. Yeah, the sensor's internal circuitry then converts this differential signal into a digital output. Then digital output. Typically, you can say it's a high or low, 0 or 1. 0/1. So this is the working of that PIR sensor. Yeah. So how it is working? In idle state, both slots, the PIR sensor detect equal amount of infrared radiation from the environment. No significant signal is generated as there is no differential change. When a person or animal is going to enter the sensor detection area, one slot detects more infrared radiation than the other. This created differential signal change, and the sensor register this change as motion. Yeah, as a person moves across detection area, this is the detection area, and person is going to be move across this detection area, the infrared radiation levels changes across both slots and create differential signal. Then sensor continuously detects these changes and maintain a high output signal as long as differential changes persist. Yeah. And the person moves out of the detection area, then Both slots return the detecting the same amount of infrared radiation. The differential changes stops and the sensor return to its idle state again, and it will give low output signal then. That's how the infrared that in PIR signal is working. So PIR sensor is working. Now some more things we need to discuss about the sensor as well. Sensitivity. Some of the feature we having inside that as well. Sensitivity. The sensitivity of PIR sensor can be adjusted in some models. Yeah. This determines how much movement is required to trigger the sensor. Range. PIR sensor have a specified detection range. I think it's usually in meters. It's depend on sensor to sensor. This range indicates how far from the sensor motion can be detected. And we having the field of view inside that as well. There are some these are the some terms which you can need to be consider when you are going to use any PIR sensor. Field of view. The field of view indicates the angle. It indicates angle within which the sensor can be detect motion. So these are the three things we need to be consider whenever we are going to get any PIR sensor: sensitivity, range, and field of view. And there are lots of application of PIR sensor we are having: security systems, automatic lighting, energy management. Yeah, lots of things are there we can create using that PIR sensor. Yeah, and one of the system we are going to create today, and for that we are going to use the Tinkercad, and we are going to do code for that the same as well. So now I'm going to stop sharing that screen. I'm going to share the Tinkercad. um, Tinkercad, Tinkercad. And circuits. I think I need to share the screen again. Screen and Tinkercad. Yeah. So first of all, I am going to take an Arduino. First of all, and I am going to take an PIR sensor as well. As you can see, this is the PIR sensor. In the reality, it is looking like same as well. Yeah, PIR sensor. So you can see some images of PIR sensor over there as well. It's looking like the football structure uh, over there. But what you need to do, identify this pin over there. You can find this pin easily in the Tinkercad. It is signal, it is power, and it is ground. So you can find that it's output pin, it's 5 volt pin, and it's ground pin. But how you will check in that thing? So what you need to do, you need to remove that football over there to check out the pin configuration. If we have that pin over there, now you can see this is the PR sensor structure over there. PI sensor without football structure. Football, I'm also saying football. Football structure. I think I think you need to check by yourself. So one of the pin is VCC, one is that. No, it's not showing over there. Hmm. You need to remove this football to check out the pin diagram. Yeah. So, and you can attach that upper body again after checking which pin is VCC, which pin is output, and which pin is that ground. So again, I'm going to connect this power with that 5-volt pin. So I'm going to connect this with the 5-volt. And ground to ground. And I will change the color over there as well. This is going to be black. This power is going to be red. And the signal pin I'm going to connect in one of the digital pins. I'm going to take pin number 7 for that. You can take any pin over there. I'm going to choose 7. The color I'm going to check is the green. So this is my circuit diagram over there. And what I will do, I will create a system where if motion is going to be detected, then a buzzer is going to be create a sound. It's a security type of system. If someone is around, moving around my house in the night, then my buzzer, my alarm, my light, everything is going to be on, and then I can save my all the items via the from the thieves. Yeah. So now for that buzzer, you can connect any number of devices, but there I'm going to connect the buzzer. So I will connect negative of buzzer to the ground, and positive of buzzer to pin number 9. This is going to be red, and this is going to be black. So I am done with my circuit. Yeah. So what I did, this PIR module I have connected with the Arduino. That VCC or power pin I have connected to 5-volt. This ground pin I have connected with the ground pin of Arduino, and this output pin of that's that PIR sensor, signal pin of that sensor I have connected to pin number 7 of Arduino, digital pin number 7 of Arduino. And then I have taken a buzzer to indicate someone is moving around the sensor. So I have taken a buzzer for over there. Then buzzers positive I have connected pin number 9, and buzzers negative I have connected to ground. So this is my whole circuitry. You can check over there. And now what I'm going to do, I'm going to create the code now. To create the code, you need to click on the code. Then what you need to do, you need to click on the blocks, you need to click on the text coding and continue. I'm going to delete all this code from there. Or what I will do, I will remove this pin mode and these all the things over there, pin mode, and I'm going to delete this code from there. I will keep this void setup and void loop. So first of all, I'm going to define that pin of the sensor. And PIR is going to be connecting pin number 7. I have connected on the pin number 7. And int buzzer, I have connected to pin number 9. That's it. Now in the setup, I need to tell microcontroller Arduino. Okay, Arduino, pin mode. I have connected this PIR as the input, and I have connected pin mode, buzzer as output, and I'm going to communicate Arduino with console as well. So I will start serial communication as well. Serial dot begin with the speed of 9600 baud rate, and what I need to do, I will write the logic over there. Okay, so I will create a variable int motion, and then motion is equal to digital read, and whatever the PIR reading and whatever the output PIR providing to Arduino is going to read that output. It can be either 1 or 0, and it will give to the motion, and this 1 and 0 is going to store inside the motion whatever the output, or whatever the output this sensor is giving to the Arduino. Whatever the output sensor giving to Arduino, whatever digital signal sensor giving the Arduino. So when it detects motion, then it gives 1 inside the motion. When it detects rest, then it will give 0 into the motion variable. Okay, so how it's going to work? So when there is a motion, means that infrared radiation across the slots of that PIR is going to be change, and due to this change we can detect, okay, there is a motion, and then it will give 1 to that Arduino. And when both slots having the same infrared radiation, means there is not anything in the motion in the background, then so in that balance thing, it will give 0 to that motion variable. So now I'm going to create the condition over there. If motion is going to be high, then what I want to do, I want to make this buzzer on. So digital write buzzer is going to be high. Or what I will do, I will compare motion equal to 1. Else digital write buzzer is going to be off. Buzzer is going to be low. So this is the code I have did, and side by side I will print that value of that sensor as well. So I will do serial dot print ln motion. I will do serial dot print motion colon space, and in the next line, so in after that, serial dot print ln, I will print that value motion. So this is the string which I'm going to print first, motion colon and space. After this space, I'm going to print this value motion. It can be 0, it can be 1 according to the condition. Yeah, we are going to check over there. And that's it. For a better stability, I will put a delay over there. Delay is going to be 200, and that's it. So I think we are good to go. I will start simulation, and I think we don't have any error in the code, and motion is 0 now. You can check. Yeah. Now, if I click on the sensor, this sensor is in now rest. Yeah. This is the object. This green thing is the object. 1 second. This green thing is the object. Yeah. And it is in the rest now. It is not moving. When it start moving, if I move my cursor like this, you can sense my buzzer is creating sound now. Yeah. If motion is there, then buzzer will be on. If it is not moving, then buzzer will not create any sound. If it is moving, you can see on the console as well. The console as well, in the serial monitor as well, we are getting 1. Yeah. And otherwise we are getting 0. We are getting 1, motion 1, when object is moving, and buzzer is also on. Yeah. So this is a security system you can create. You can create multiple devices over there as well. You can connect an LED, you can create multiple device, you can control your whole home electricity over there as well. Like generally we can make our lights off in the night time, and we uh, off our alarm as well. In the night time, what we can do, in the daytime the alarm will be off, in the night time alarm will be on. Okay. And whenever in the night time is going to be walk through near our room or house, then all the lights will be on and alarm will create a huge sound. And then in that condition, thief will run away from that condition, and we can save our very expensive things. Yeah. So that's how that technology can help us. And we can create energy management system as well. We can create anti-theft system as well. We can create lots of things. Yeah. And I think some of the things we can attach to that train as well. Yeah. So whenever an animal, like big animal like elephant, or whenever train is crossing through the jungles, so it can detect that those animals from a particular distance, and it can create a sound. Okay. So animal can walk through from that track, and then lots of animals can be saved from that technology as well. And the train also not get any damage by these things. So this is the thing we can implement and we can learn. Okay. So this is about PIR sensor, and the basic and the code and the interfacing. And we will learn about the motors, how we can interface servo motor, stepper motor in the upcoming sessions. Till then, bye bye guys, we'll meet in the next class.